Hello, and thanks for tuning in to Module 2, Lesson 2. Our learning target today really builds a lot on the ability to multiply numbers by powers of 10 like we practiced yesterday. And so today we're going to be building on that with estimation. The learning target is I can estimate multi-digit products by rounding factors to a basic fact and using place value patterns. So today we're going to practice what we did yesterday by using the associative property to multiply numbers and rearranging them to make it easier to multiply them together. Just like yesterday, you are going to need your laptop and headphones, which you probably already have, but you're also going to need your Learn book and your notes. Please make sure that if I am doing work on the screen, please make sure that you are taking notes as well. Let's get into it. So today we're going to be talking about estimation. And estimation is a really, really powerful skill. And it's about finding friendly numbers that make it easy for you to do mental math. So let's say, for example, last year, I know that 93 students came to our Chuck E. Cheese night. So if 93 students came, and I know that each student played on average 8 games. And I want to know how many games were played altogether. I would have to multiply these together. 90 times 8. Excuse me, 93 times 8. But instead of actually using the standard algorithm, I can just estimate. I'm going to round this to a super friendly number. So I'm going to round this up to 100. And I would round 8. I could round that up to 10. And so I would say 100 times 10, and I would know that that altogether there were about 1,000 games played at Chuck E. Cheese night, and that's a lot of games. That's a lot of fundraising. So that's just a practical application for estimating. So in your notebook, with leaving a little bit of space, we're going to solve these 3 problems. And we're actually not going to use the standard algorithm today. Instead, we are going to round and we're going to estimate. So I'm looking at these numbers and I'm thinking about where I could round them to make them easier to multiply. When I first see 456, my first reaction is to round it to the nearest 10. So I would round it to 460. And when I see 40, I would also round that to the nearest 10 and I would get 40. Now, this does make the problem a little bit easier, but I still am not sure I can do this in my head, 46 times 4. So instead, I'm going to round this number, not to the nearest 10, but I'm actually going to round it to the nearest 100. And so I can do 500 times 40. And I learned yesterday that I can use the the associative property to rewrite this as 5 times 100 times 4 times 10, and then use the associative property to rearrange how I multiply. So 5 times 4 is 20, and 100 times 10 is 1,000. So when I multiply them together, I get 20,000. And so that's how I can estimate this product without actually using the standard algorithm. Let's keep this in mind as we look at a similar problem. Now, the only difference is that this has a 0 on the end. So the number in the multiplication problem is 10 times bigger. So let's take a look at how that impacts our estimation. Again, I'm not going to round this to 4,500 or 4,600 because I can't multiply 46 times 4 in my head. So I'm going to round this again now to the nearest 1,000. So I'm going to round this up to 5,000 because that's a nice simple number to multiply. 5,000 times, and I'll round this one to 40 again. 5,000 times 40. I'm going to rewrite this as 5 times 1,000 and 4 times 10. And I'll use the associative property to multiply 5 times 4 is 20. And then 1,000 times 10 is 10,000. So now my product is going to be 20 times 10,000, which is 20 with 1, 2, 3, 4 zeros after it, which is 200,000. So I was able to estimate this to 200,000 without using the standard algorithm. Now I see that this problem is the same as the one before, except now this number is 10 times larger than this one. If the number in our problem got 10 times bigger, what do you think is going to happen to our product? Let's take a look and see. I'm going to round my first number, 4,560 up to 5,000 again. And then I'm going to multiply, I'm going to round this one down to 400. What's 5,000 times 400? 5,000 times 400 is going to be 5 times 1,000 times 4 times 100. So I'm going to get 20 times 1,000 times 100, which is 100,000, which is just 20 with 5 zeros afterwards. 3, 4, 5, which is 2 million. Let's use this same strategy and let's see if we can apply it to another problem. Okay, 1,320 times 88. I have a couple choices. I can try to round this to 1,300. Let's go with green. I can try to round this to 1,300 times 90. Or I can round it to 1,000 times 90. Which one do you think would be easier to round and multiply? I think that it's going to be easier to multiply 1,000 times 90 because I would have to find 13 times 9. So I'm not going to do this one. I'm just going to do 1,000 times 90. What's 1,000 times 90? I could rewrite it as 1,000 times 9 times 10. And I know that 10 times 1,000 is 10,000. So it would just be 9 times 10,000, which is 90,000. Let's use this same strategy and see if we can solve 13,205 times 880. What do you notice about 1,320 and 13,205 and 88 to 880? I notice that this is basically the same number. It's just 10 times larger. If this were a 0, it would be exactly 10 times larger. I also notice that this would be 10 times larger. If both products, if each one is 10 times larger, what do you think is going to happen to our product? Well, we could round this to 10,000, and we could round this to 900. I could rewrite this as 9 times 100 times 10,000. I know that 10,000 times 100 is 1 million. So it's going to be 9 times 1 million. 9 times 1 million just equals 9 million. How do these two products relate? We saw that each one was 10 times bigger. This one was 10 times bigger, and this one was 10 times bigger. How did that change our product? Well, I can see that this one has 6 zeros and this one has 4. So this product is actually 100 times bigger. And that makes sense because this one was 10 times bigger and this one was 10 times bigger, and 10 times 10 is going to change our number by a factor of 100. Here is our exit ticket. See if you can round the numbers in all three of these problems to estimate the products. In these problems, you should not need to be using the standard algorithm of multiplication. Your goal is to round and estimate, so you don't need to find the exact answer. Good luck.